Okay, hello. This is the lecture 3, the recorded part of the lecture 3. In lecture 3, we studied basic programming of the PLC and how to convert a hardwire control system, control circuit to a PLC-based control system. The program that we work on that was this one. This was the hardwire control circuit. We studied how to convert that to a PLC program. The PLC program as a schematic is this one, together with the input and output connections. And but the PLC program, the whole PLC program, as of the Siemens format and according to the input outputs, is this program. And we are going to build this program in the by the PLC software and download that on the PLC and do the experiment. So in this session I'm going to build this program from the scratch and build that, download that, do the wiring connection, and then do some experiment with that. Let me remind that the trainer that you have is this trainer. Okay, let me zoom out that. This is your trainer. Okay. In this trainer, you have PLC and HMI. The PLC and HMI that you have is similar to the PLC and HMI that we have here. Let me show that to you. Yeah. The same PLC and the same HMI that you have. And maybe a little bit on the version is different, but the same structure. But in your trainer, you have also some process, heating system, DC motor and step motor system. I don't have these. Instead, in my trainer, I have all the input and output terminals of the PLC here, and then I can wire them to the devices. So in your trainer again, you see that your zoom in. Here you can see that, okay, you have the inputs, there's some switches, some for push button and some for toggle switch or selector switch that are connected to the inputs, and this is the wiring of that. You don't need to do wiring, but and also for the outputs, they are connected to some pilot lights, okay, red pilot lights or yellow and green pilot lights. But in my trainer, I just have the terminals here that are wired to the PLC. This is the digital input, this is the digital output, this is for the analog inputs. And I need to wire them to the push buttons. Here I have two push buttons, green and red. I use these two similar to your push buttons, the green and red one. And also some pilot lights that I need to wire them. Also in your trainer, in this example, you're going to use the heater. You have a heater that the digital output number 0 is connected to that, and so when you energize digital output number 0, when the state of that is 1, the heater turns on. I don't have a heater, but instead I use a motor, electric motor. Also you have a temperature sensor switch, let's say temperature switch, that can sense whether the temperature is more than some threshold value. This is the overheat sensor in our program. Instead of that, since I don't have the heater, I use an electric motor, turn on the electric motor, and instead of the overheat temperature sensor, I use a switch, just a switch. By turning it on and off, it simulates the overheat switch. Okay. I keep the wiring. You don't need to do any wiring in your trainer, but since the wiring and the relation between the hardware and the software is one of the important part and important concept in PLC programming and PLC control system, so I do the wiring in front of the camera to show you the wiring and how the devices connect to the PLC here in this recorded session. Okay, so let's first start with the program. We are going to build a program. So let's open the TIA, Totally Integrated Automation program. Please take care of that. This part, I have the TIA in my laptop, in my computer. So I just simply open that as an administrator. Depend on how the TIA is installed in your computer, maybe you need to do some initial steps regarding any kind of start step, or maybe it is the same. It's something that you should check with your IT specialist. So let's run that. I run that as administrator. Okay. Okay. So the first step is to set up the configuration and connection between the PLC and the PC. So let me create a new project, and okay, let me call this project, for example, heater control. Okay. Yeah, you can select the folder. I have a recorded version folder, so I save that on that. And this is a really for the version of the software. The version that I'm using is a version 14 that I believe that it is as you have. And you can also use your change the outer name if you like. Let me change that as address. Okay, so create. This is just creating the program for the heater control system. Then we should set up the connection between the PLC and the PC. Okay. The program has created. Then first select the proper device. To select the proper device, I mean that the PLC or the HMI. This example, just the PLC. In the next example, we also add the HMI. So click on this configure a device, and then add a new. Okay, controller and HMI. Select the controller under this menu, Schematic 7, and then open the CPU. The CPU that we have is this one. This type is the one that we have, and it is the same as the PLC that you have in your trainer. Okay, when you select that, leave these as a default, and then add. Okay, this add a PLC with this type to your program, but you should define that this PLC is the PLC that we have in the trainer. So although the PLC, the software, the program, you select this type of PLC, but you should say that, okay, this is the exact PLC that I'm going to connect with that, because maybe there are more than one PLC here. So it's important that you define that. To do that, here you have, there are two options. One option, simple option, is to double click on this one. Okay, so let me double click on this one, and then if drag this up, okay, here you can see that the properties of this PLC, all the properties of this PLC regarding the connection, network connection, regarding the I/O and like that. We need only to set up the IP address for that. So under the general tab, find the Profinet interface. Okay, this Profinet interface, and under that, Ethernet address. And the Ethernet address, if you go down here, you can see the IP address. There are some default IP address that is given to the PLC by the software. You can change that. The IP address for your PLC is 192.168.0.2.0.7. So let's define the same IP address in this PLC too. So this is the address. This is the address for the PLC. But if you're going to connect the PLC or any other devices to their computer, all of them should be in the same domain. It means that the first three numbers here should be exactly the same, 192.168.0. And the last one is the device number that you should assign to each device a different numbers. For the PLC, the number is 207. For the HMI, we use 205, and for the PC, 200. So to check whether the IP address of the computer is also in the same domain and that's correct, you should open the network and share network sharing. So to do that here, this is for the network. Of course, since I am connected to the through the Ethernet, through the wireless, so it shows as a wireless. Maybe in your computer it is as a wired connection. So right click on that and open network. Okay, open network and internet setting. Here this Windows pop up. Under that, select the Ethernet and then change adapter options. Change adapter options. Here you see all the network adapters and devices. So the Ethernet is this one. You see Intel Ethernet connection number or something. Also there are Wi-Fi. Maybe you have some VPN or some other Bluetooth or like that. So this is the one that is the Ethernet. So the double click on the Ethernet. When this Windows pop up, select the properties and then Internet Protocol TCP/IP4, the same as that we did in the first two sessions. So select this one and then properties and check whether the IP address is correct or not. If not, you should change that according. So the first three digits should be 192.168.0, the same as the PLC, and 200 for the PC. And also the subnet should be 255, 255, 255, and then 0. It is correct, so just OK, and close, and close. Okay, that's correct. So the PLC and the PC are in the same domain. We should should connect them. To connect them, you can go online. There are many options. One of them is to go online, try to go online, and then the software asks you, or accessible select this accessible device, or then you build the program, try to download. In all of these cases, it asks you to whether connect or not. So let me just build the program and then try to download. Over there, it asks us whether to connect to the PLC and finish the setup step for the PLC. So program blocks to build the program under the program and then on the PLC. This is the PLC number 1. This is the one that we selected. Let me first show you the accessible PLCs just once more. So here, click on these accessible PLCs to be sure that this is the PLC that we are going to connect that. Okay, the Profinet, select that. There are some other options. This is Ethernet, and then start search. So there are 3 devices. These 3 devices in this trainer is the PLC, this HMI, and this HMI. We are not going to use this, just this PLC, and later this one. We don't use this one. So here also you can see there are 3 devices. This is the PLC one that we are going to use, and this is the HMI one that we are going to use, and this is the other device that we are not going to use that at all. So this one, select this one, and show that. And this is PLC number 1. Okay, so it is PLC number 1. So we select the correct type PLC device. Okay, so then just here drag up, and then here you see PLC number 1. Okay, under the PLC number 1, select the program blocks, open that, expand that, and then the main OB1. Double click on that. When you double click on that, okay, this is the a blank file for building the program. We build our program in the main OB1. What's that? We will look at that at the last session regarding some advanced topics on the PLC. But this is the one that we use in all through these programming, all the programming in this lecture. Okay, so you're going to build the program here. Let me just expand, minimize this so I have more space to look at that. And the program that you're going to build is this one. Okay, so start, stop, start, overheat, heater as the output. This is the heater as the self-holding, and 3 pilot lights, green, red, yellow. Try to memorize that. Just of course we can back again. Stop is the 0, 1, start is 0, 0, overheat is 0, 3, and the heater is Q00. These are consistent with the switches that you have here. So you see, start 0, 1, 0, 0, stop, the red light, the red push button is 0, 1, and the heater is Q00, and the overheat switch is input 3. So this is consistent with this IP address that you have in your trainer. So let's use them. So to build the program, first select the Siemens PLC divide the program into different networks. Of course, there are more division, but let's just concentrate on these networks. You can build each line of this program, okay? Each line of this, something that we call each rung of this, RUNG, each rung of this, okay? In one network, or you can build all of them in the same network. There are some difference between them, but for our cases, there's not any difference. There's not any difference in our case, in our programs, but there are some difference between building all these branches or all these rungs in the same network or not. But it's not related to our program. So let me do the practice both cases. First, we need 3 normally open and 1 output. Okay, these are normally open and the output. These 3, okay, and the output. Let me show you again how I select these. Let me delete all of them and show you again. Okay, I select them from here. Okay, this is the normally open. Again, 1 more. Okay, 1 more, and then an output. This is for the output. Okay, or assignment. It called that assignment or the output assignment. Okay. Also, I need a branch here. This is the branch I need here to build this branch. Between these 2 contacts, you see that there's just, if you click here, the color change or the shape of that change, and then using these 2 you can build a branch. By clicking on this, a branch is appeared here. Then we need a normally open here, and then connect that to here. Just drag that to here to connect that. Okay, so, and then let's define the contact variables. This is the stop. Stop was input 0.1. Okay, double click, and when you click on that, then the software automatically assigns some tag number. This tag number is very helpful in especially large programs. The tag number is unique, so you can change that. To change that, select that, and then right click, and then rename tag. Select the rename tag. This is supposed to be stop, so select the stop. Change that to the stop. This is the start, so input 0.0. Okay, and then here again select that by just click on that once. If you double click on that, this menu opens. This is different. This is different. We are not going to change that here. It's right click, just select that, and then rename tag, and this should be start. And this is going to be input 0.3, and tag for that is going to be overheat. Overheat. And this is output 0.0, Q 0.0, and then double click. Please take care of 0 or O. It is 0.0, and this is going to be the heater. Okay, here also is the self-holding. Let's show that to you again. This is the self-holding. You see that the same address as this one, the same address as this one. In fact, this is the same variable. These two are the same variable. So let's use this as Q0.0. And when I click that, you see that the heater automatically appears because the tag of this is heater. Okay. To add the next, the branch, okay, to add this branch, select again the left rail, and then again use this branch, open branch. Click on that, and then we need to normally close. You see that the program, the software automatically adjusts the position according to the space that it needs. So, and then we need an output. Okay, this is going to be, okay, it's going to be heater. It's going to be the heater, so the same address. There are two options. One is to use the address, the other is to use the tag. For this one, we use the address. We add the address here for that one, and the tag appeared automatically. As a practice, this time I use the heater, the tag of that heater. Okay, just heater, and then double click on that. You see that similarly, the address appeared automatically, and this is very helpful in, especially in the larger scale programs that you have lots of input outputs, hundreds or thousands of input output addresses, and it's very difficult. It's nearly impossible to memorize all the addresses. It's very difficult, but the tags are more are simpler to be memorized, because generally we select the tags according to the something that we expect. For example, oven 1 heater, or overheat of oven 1, for example, or furnace number 1. Okay, so we use the same the tags according to the application, and so it's much simpler to memorize them. Okay, this is going to be their green light, Q0.7. Why Q.7? It's because in your trainer the input number 7, the output number 7 is connected to the green light. So I use the same address here, and let me change these to green. Okay, and again one more branch. I need one more branch. Click here, and then again one more branch. This time normally open, and the output. This is going to be heater, and this is going to be Q0.5. It was red, so tag the red. Okay, and finally this overheat. Just as a practice, also in this file, the overheat is also in the same network as the other branches, but I just add this in another network, just as a practice. So instead of continuing adding a branch here, I just skip that and go to the network number 2 and add normal close and output. It's the same. There's not any difference from our point of view. So this is the overheat. I don't remember the address, but I don't need to memorize that overheat. So simply connect on that. And then this should be Q0.6. And the tag is yellow. The tag is yellow. Okay. So the program is ready. The program is ready. Check that to be sure that everything is correct regarding the input address, regarding the tag numbers, regarding the type of the contacts, whether they are normally open or normally closed. If it is, there's in the PLC, Siemens PLC, there's one default network at the end without anything. Leave it as it is. You don't need to remove that, but you can also remove that simply. So let's leave it as is, and then so this is the program. We build this program according to what we need, and now we are going to check that. First, to download that. Before downloading, it is important first to compile that. This is the compiler. Here is the compile icon. Click on the compile, and again, if I okay, it's doing the compile. Okay, if I drag this upward, okay, here you see that the result is here. There's not any error on that. That's good. If there's any error, you cannot download that to the PLC. So if there's not any error, let me compile that again to show you what will happen here. Okay, it is something happening. Then you can download. This is download to device. So let me download to device. Again, it asks which device. Okay, which device? Because we select this type of device, but we have not yet connected exactly to this device. So it asks which device. There are three options here. I told you in the previous session regarding the same address, compatible, and accessible. Let's use this compatible device. Compatible device means that it looks for any device that has this type of CPU. So start search. Good. It's the find out that, and then I can select to load that. Okay, here it might ask you this, depend on your program. Sometimes it asks this, for example, regarding the synchronization. Just continue without synchronization. Just select this one, and here it asks, this is important, the PLC, we cannot change the program of the PLC when it is in the run mode. It should be in the stop mode. Okay, so when you try to load the program, if the PLC is in the run mode, it asks you whether you want to stop the PLC and then download the program or not. If you don't stop that, you cannot load that. You should select the stop, so the PLC does not work anymore. It's just in a stop mode, and then it is the time that we can load the program on that. Okay, and then the download, it again is asked whether you want to start that. Let's say set that in the run mode. If you say finish, if you click finish when this is selected, it means that it is started the program. If not, you can simply say that no, I just want to download the program, but I don't want to start the PLC to start to run that. Just save that in the PLC and leave that to later. But let me just start that. So not only download, but also the program is now is running on the PLC. Okay. When you have the program in the PLC, if you have a computer connected to the PLC, you can see the state of the input and outputs and all of the variables in your PC too. You can see the state of them because the PLC does not have any monitor, but you can see the state of the variables in the PC in the software. How to do that? Okay, let me again drag it down. To do that, there's one icon here. It's called monitoring on off. In fact, if you click on this, then the state, the color, let me click on that. Okay. Then I'm monitoring the state of the variables there. If a variable or a connection is green, it means that the state of that, the logical state of that is 1. And if it is blue, the dashed blue, it means that the state is 0. So right now you see that the stop input is 0 because there's not anything connected to that, so it is 0 and it is blue. And the start also and the overheat, all of them are 0. And the heater is off. And the heater is off, so it is blue. And here you see that since the heater is 0, let's say Q0.0, the state of that is 0. So, and here we use the not of that. This is a normally closed, and the normally closed, you studied that it is not. So the state of this contact is 1. The state of the variable is 0, but the state of the contact is 1. The state of the contact is 1. So you see that since this is the this is green, or let's say this is the supply, true, and since this is green, it means that the logic 1 can pass that, and so the green here shows that the Q07 is 1. The logic of that is 1, and if you look at the PLC, of course it's a little bit far, but the light for the output 07 is on. It means that the output of that is 1. Okay. And it means that if you connect the output to some light or something like that, it turns on that. Okay, so this is the program. The program is ready and it is running, but we need also to do the wiring. The wiring, and the next step is this. So let me do the wiring. The wiring is according to this figure. We have 3 switches, a normally closed for the stop, a normally open for the start. We need a switch for the overheat, and also a coil for the an output for the heater, and green and red light. We also add the yellow lights that is not indicated here. The yellow light is for the overheat. So I'm going to build this wiring. So this wiring is something that we should do. The wiring means that, for example, from the 24 volt connect to the switch, and from the other terminal of the switch to the PLC input, or from the PLC output to the heater, or in my case to the motor, and the other terminal of that to the ground. For the lights, the same. So from the output module to the pilot lights, and the other terminal of the pilot light to the ground. But in the PLC, in addition to these wirings, let me show you something else. In the addition to these wirings, this is for the inputs. So we should connect the 24, and here I have the power supply, 24 volt and ground. So this is the power supply, 24 volt terminals, and these are the grounds. And also I have the digital inputs and the digital outputs. I have push buttons and lights and motor and switch here, so I can wire them. But in addition to these wiring, each input or output devices might have some common terminals. The common terminals should also be connected to the power supply. Depend on the type of the PLC, depend on the type of the card, the COM might be connected to the should be connected to the ground or to the 24 volt. This is something that we should check in the data sheet of the PLC. The data sheet of the PLC. For this PLC, as I mentioned, you don't need to do this wiring in your trainer. Everything has already been wired. But for this PLC, the input COM terminal must be grounded. Here in this trainer, it shows as a black terminal, and for the digital output, the COM should be connected to the positive or 24 volt. So first, let me connect this one to the ground. This is to the ground. Okay, this is the base I need, and this COM to the 24 volt. This is something that we need. Okay, this is. Let me emphasize that these are different from the wiring that you have here. Okay, for the wiring that we have here, okay, so we have start and stop, green and red, green for the start and red for the stop. In your trainer, green is a normal open and red is a normal close. In my desk, the green has both normally open and normally closed terminals, and the red also has both. I use the same terminals as you have in your trainer. So I use only the normally open for the green and only the normally closed for the red. So it's consistent with your trainer. So first, from 24 volt to the normally open of the green, the start, and the start input was input number 0. Okay, so the other terminal of that is this connection, this from the 24 volt to the normally open for the start and from the normally open to the input is in fact these wires here, from the 24 volt to the start and from the start to the input. It is this wire. Similarly for others. So let me do for others also here from 24 volt again to the normally closed, because the red, the start is going to be normally closed, and from the normally closed to the input 1. I don't have the overheat switch, but instead I use this simple selector switch instead of that. Again, from 24 volt to this switch, and from this switch to input 3. Input 3 was the input that I had for overheat. So this is for the overheat. These are the inputs. For the outputs, I have a motor, electric motor instead of the heater. So I use this one from output 0. Wire this one. From output 0 Q0.0. Okay, here please notice you see 0 also here and 1 here. This is Q0.0, 0.1, 0.2, 0.3, 0.7, and this is Q1.0, 1.1. It has 10 digital outputs. 8 of them are Q0.0 to Q0.7, and the other 2 is Q1.0 and 1.1. For the input also it has input 0.0 to input 0.7, input 1.0 to input 1.5. Okay, so 0.0 is this one. So let me connect that to the motor. Okay, and the other terminal of the motor to the ground. This is the ground. Okay. So this connection from the 0.0 to the motor and from here to the ground, in fact, is this connection. This connection from the output to the motor or heater for your case, and from the heater to the ground. And I need also for the red, it is let me see the addresses for the red. Red is 05, green is 07, and yellow is 06. So from output 05 to green, output 07 to green, 07 to green. This is the green. Press to the back. To the 7. And the other terminal of that goes to ground. Okay. And also from 5 is for the red. So this for the red, 5 to the red. And the other terminal of the 5 goes to ground. Ground. And finally, for the yellow, it is from 6. So from output 6 to the yellow final pipe, and from the yellow final pipe to the ground. Okay, okay. Let's. So the wiring is complete. Hopefully, let's check that everything is fine. To check that, let's see the program. According to the program, Q0.0 must be off. So the motor is off, that's correct. Q07, the green must be on. And you see that it is on. The red light should be off. Yeah, it is off. And, okay, the overheat right now is on. The overheat light is on. Why this is on? Because the overheat itself is off. Here you see that the overheat is off. It means that there's an overheat, of course, there's not any switch, rear root switch. So let me just switch it on. When it is in the on position, when it is closed, here you see that it is green. When this is green, it means that this contact is closed. Or let's say this contact, the logic of this contact is 1. It's because the logic of its input is 1. It is on, you see that? It is, let me show you here. You see, there's an on here. So it is, when it is in the, in the upward position, so it is on. When it is on, the switch is closed, and so the 24 volt appears in the input, and when the 24 volt appears in the input, when 24 volt appears in the input, the logic of this is 1. When the logic of this is 1, the logic of this input 0.3 is 1, so the logic of this contact is 1. And now, the only thing that I need to turn on the heater is to turn on, push the start, because this is on and this is connected. This is off, so it is not connected. You see that it is blue. This is on, but because before that there's not any logic before that, so there's not any after that. So the logic before that is 0, after that is also 0. When I push the start, if I push the start, this becomes 1, and as a result, this line will be connected. Let's look at that. So I'm going to push this start, okay, and something that I expect is that when I push the start, the logic reaches to this point, and this is closed, so this continues the logic to reach to the heater, and the output turns on, and the motor turns on. Okay, so let me push this and see what will happen here. Okay, you see that? When I push that, this closes, and so all of them are closed, and so the heater are closed. And when the heater is closed, this also closed. This is the contact, that the state of that is similar to this one. So even when I release the start push button, you see that this turns off. Okay, so the logic cannot reach to the heater through this branch, but it is continue to reach to the heater through the self holding. This is the self holding, and so the heater is on. In my case, the motor is on, and now you see that the motor is on. Okay, and the red light turns on, the green light turns off. Why? Because according to the program, the red light is shows that the heater is on, and the green light shows that the heater is off. When the heater is on, so the red light goes on, and this is something that works there. So let me start and stop that. Then I push this stop. You see, the motor turns off, the red light turns off, the green light turns on. Again, start that, the motor turns on, the red light turns on. That indicates that the motor is on, and the green shows that it is off. Okay. What about the overheat? Overheat, in fact, happens when the temperature is more than some threshold value. In your system, you have the overheat switch, so automatically it turns on. In this trainer, I don't have overheat, so instead I use this switch. Something that I expect is that when I turn, right now, the switch is on, so the switch is closed, and so we can turn on the heater. If there's an overheat happens, the switch turns off. This is a normally, let's see, it's a normally, it's a normally closed heater. It's a normally closed switch. So when there's not overheat, it means that when there's not overheat, in normal case that there's not any overheat, this is closed, and this is something that you see in the program also. It is closed. Okay? But when there's an overheat, this opens. When this opens, then something that we expect is that this opens and the heater cannot turn on. Okay, let's see. Let me open that as if there's an overheat. You see, the motor turns off. Here the motor turns off. And not only this green light shows that the motor is off, but also this yellow light shows that it is because of overheat. So the motor turns off not because somebody pushed the stop. It's because an overheat happens. You see, an overheat happens. So it is different from that. Let me do the experiment again. So let's assume that there's not any overheat. We can start. We can stop. You see, it is stop, but there's not any overheat, so it doesn't turn on. It just shows that start and stop, simple start. But if there's any overheat, not only stop, the motor stops, and this light turns on, but also this overheat light also turns on. This is an indicator to the operators that there's an overheat. What to do? It's the next step. Depends on the application. Okay, that's all. This is a first program. There were many basic issues to be handled. The program is not very complex, but there were many issues regarding the wiring, regarding the how the logic works, how to monitor the programs. Now we get familiar. We are going to use this concept for more complex programs. In the next step, I'm going to add the HMI. In this experiment, we didn't use the HMI. We only use the PLC and communicate with the PLC and understand the PLC using these networks. Please notice that the program is something that generally operators doesn't use that. Otherwise, there is some special reason to look at the program to, especially for the diagnosis and maintenance. But in normal operation of the in the industry, operators just work with these switches and lights. Look at the lights and understand, okay, there's an overheat. They look at the light and they can understand that there's it is in the stop mode or in the stop mode. But instead of using these lights and instead of using these switches, we can use the HMI. Okay, and turn on and off the motor on the HMI or indicate the state of the motor or the heater on the HMI. This is the next step that I'll show you in the next. I stop this recording session at this moment, and in the next recorded session, I will show you how to build the same program, the same, let's say, control system, but instead of having these switches, just use the HMI and the PLC